In this video, we will prove the vector identity that the divergence of cross product of two vector fields A and B is equal to the dot product of the second vector field with the curl of the first minus the dot product of the first vector field with the curl of the second. Suppose you have two vector fields A and B. So divergence of divergence of the cross product of two vector fields A and B is equal to the dot product of the second vector field, that is the vector field B, with the curl of the first vector field, that is A, minus the dot product of the first vector field, that is A, with the curl of the second, that is curl B. We have to prove this. We know del operator can be defined by I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z, and you take the dot product with the two vector fields A cross B. So this is your A cross B. Now you first consider the x component of the vector field A and B. Here you have taken three components of A, that is I cap Ax plus j cap Ay plus k cap Az, and also you have three components of the vector field B, that is I cap Bx plus j cap By plus k cap Bz. So if you take the x component of the vector fields, then the dot product of this I cap partial derivative with respect to x with these two vector fields will be equal to I cap dot partial derivative of Ax with respect to x cross Bx plus Ax cross partial derivative of Bx with respect to x. So this is two components for the ith component or x component. This will be equal to I cap dot partial derivative of Ax with respect to x cross Bx plus I cap dot Ax cross partial derivative of Bx with respect to x. And we know in a scalar triple product, position of the vector and cross can be interchanged. So if you interchange cross here and dot here, then the first term will be equal to I cap cross partial derivative of Ax with respect to x dot Bx minus y minus, because A cross B is equal to minus of B cross A. If you write partial derivative of Bx with respect to x first, then x second in the second term, that means A cross B is equal to minus of B cross A. So that will be equal to minus of B cross A. And if you interchange cross product to cross with dot, then you have I cap cross partial derivative of Bx with respect to x dot Ax. So in the next step, I have again again interchange the dot with cross because of it is also a scalar triple product. Then this will be equal to Bx dot I cap cross partial derivative of Ax with respect to x minus Ax dot I cap cross partial derivative of Bx with respect to x. So this is the result for the x component. Similarly, if you consider the y component, instead of Bx you will have By dot instead of I cap you will have j cap cross partial derivative of Ay with respect to y minus, here you have Ax, so Ay dot j cap cross partial derivative of By with respect to y. Similarly, considering the z component, you have Bz, By will be equal to Bz dot, here you have j cap, so you will get k cap for z component cross partial derivative of Az with respect to z minus Az dot k cap cross partial derivative of Bz with respect to z. Now you add the three terms, that is the terms containing x, y and z, to get the result. So the divergence dot A cross B will be equal to, you see, this is for the x component, bx dot I cap cross partial derivative of ax with respect to x plus by dot j cap cross partial derivative of ay with respect to y plus bz dot k cap partial derivative of az with respect to z. Here you take these three terms for x, y and z. I have written first or in the bracket, then minus you write the second terms, that is the term containing x, y and z. These three terms if you write, then minus x dot I cap cross partial derivative of bx with respect to x plus ay dot j cap cross partial derivative of by with respect to y plus az dot k cap cross partial derivative of bz with respect to z. So this will be equal to b dot curl of a, the first term in the bracket will give you b dot curl a, and the second term in the bracket will give you a dot curl of b. Okay, if you expand b dot curl a, then you will get this term, and if you expand a dot curl b, then you will get this term. So in this way you can prove that the divergence of cross product of two vector fields a and b is equal to the dot product of the second vector field with the curl of the first minus the dot product of the first vector field with the curl of the second. And this is a very important vector identity which is useful in various problems in physics.